put the word calculate. Why we select this point, I'll write this down. This is because the shear at point B crosses across the 0 line. Right? That's why we check. So remember the term we talked about earlier. So it crosses the where? It crosses the 0, right? It crosses here. Okay. And then the next one we have to check when it's what? At L/2. So we have to calculate the moment again. Moment when X is equal to L/2. So we know L/2, right, is equal to 7.5 meters. Okay, so it's between point B to point where? To point C, right? So it's between point B to point C. So we look at our equation, point B to point C. So point B to point C is this equation over here. So I'm going to grab it. Copy. Come over here. I'm going to paste. Right, so this is the function. So moment, so mx, moment at x is equal to 7.5, right? So omega, so we are given omega is equal to what? Omega is equal to 45 times 10 to the power 3 divided by 2. So minus 7.5 squared, right? Minus 7.5 squared plus by 15 times by 7.5 minus by A, which is 3. L is equal to 15 plus by 3 squared. Right, then close bracket again. Then minus by P. So P is what? 70 times 10 to the power 3. Multiplied by A, which is equal to 3. Okay, so that is the entire expression. So this will be equal to, so 7.5 squared. So minus 56.25 plus by 15 times 7.5 minus by 3 times 15 plus by 9 times by 45 power 3 divided by 2. So it's 455 or 455.625 times 10 to the power 3 minus by 210 times 10 to the power 3. So this is equal to 455.625 power 3 minus 210 power 3 is equal to 245.625. Right. So from here, we know that XL/2 will generate the what? Maximum bending moment. So if you look at these two value, right, the 245.625 is definitely higher. Okay, so from here, we are going to select, okay, we're going to select mx will be equal to 245.625 times 10 to the power 3 Newton meter. Okay, so we're going to calculate the stress allowable, or we know the stress allowable is equal to mx, right, divided by the minimum S that we can get away with. Okay, we are not finding the maximum S, we're going to find the minimum S. So S mean, so the S is the minimum, means you cannot go below that. You have to go above that. Okay, so this will be equal to 245.625 times 10 to the power 3. And we have decided to use a piece of steel that has allowable stress of 160 times 10 to the power 6. So this will be equal to 245.625 power 3 divided by 160 power 6. So it's equal to 1.535.
Eugene, I think you muted yourself again.
Can you hear me now?
Yep.
Yes. Okay, thank you. Thank you for telling me. I hope I'm not muted for too long yet. So this will be equal to so this is 1.5 1 okay times 10 to the power of 6 millimeter cube, and I have to do 1535.1 times 10 to the power 3. Okay, why is that? Because if you look at the units here, right, it's times 10 to the power 3. Okay, now so now we have this. We have to be, the minimum is 1535.1. Okay, so if we look at our table now, so 15335, so if we look at our table now, right, you can see the table. I try to maximize our table, right? So 15, so what we want is 1531, 1535, 15. I'll write over here. What we want is 1535.1. So this value is out. You cannot use this value. You cannot use that value. This one is no. 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 Oh, there's a possibility. So you can use this, right? Right? You can use this. You can also use this, and you can use anything above now. Okay. Now, so based on S mean, minimum, the S minimum, right? You can use anything above here. Right? Anything above here, we are good to go. Okay, we can use everything over here. We're okay. Then next comes to, so this is stock, we say is based on S minimum and cross-sectional area. So over here, this is cross-sectional area. This is 13200, this is 12500, and this is 1420. And if you go any higher, the area is bigger. And apparently, this is the optimum area, yes or no? This has the minimum area, right? So in industry, how do they sell steels? It's based on weight, right? The smaller your area is, the lighter. It's very obvious. So for this case, we are going to select, okay, so for this case, we're going to select S510, and then the data code is 98.2. Okay, we're going to select this one. And why we select that one is because the cross-sectional area is the what? Is the minimum. Okay, so I have another example to do with you guys. Okay, so the example that I want to do is this beam over here. Okay, so what I will not do it now. If I do it now, you guys will protest. I believe that. Okay, so what I'm going to do is I'm going to upload a video on this example, and I want you all to watch it. Okay, so this example is if you look at the textbook, is one of the most complicated example. Okay, but It's not difficult at all. Okay, I want you all to watch the video how I solve this problem, and then exactly like how I taught you guys. Okay, and then how to apply this table to select your optimum beam. If that's the case, I will stop my lecture now. Okay, I'll stop my lecture now. Don't go yet, because there's a student that